Hello, everyone. This is AI Tutorials. Today, we are going to talk about loss function. What is the concept of loss function? Why do we need it? How do we use it? And what purpose does it serve in developing our AI application? So basically, a loss function, it's a mathematical function. So it involves math. Okay, it's a function. So it involves maths. What does it do? It quantifies the difference between the predicted values by the model and the actual values. So when you're designing your model or you're writing your AI application, the main purpose is to predict something. If it is not an LLM is to generate text based and all. But normal regression, classification, those kind of machine learning models, what they do, they are mainly designed to predict the values, future values. So let's say, given these circumstances, what would be the stock price in 1 week from now, or something like that? Or given this environment conditions, what are the chances of it raining, right? So you're trying to predict something. There are different ways. Regression is continuous values. Classification is here. It's either 0 or 1. So those are classification problems. But before you release your application or you release your model, you have to validate it, that how good your model is in predicting the values for which it was designed. Like how well or how close to reality the model predicts that what would be the price of the stock or any other thing, or housing market, anything, right? So for that, the loss function is used. It checks the accuracy or the correctness of your model. Now, there are different types of loss functions. They are mainly classified as regression based or classification based. Today, we are going to talk about two regression based loss functions. The first one being the mean squared error. Okay, the mean squared error. Now, what it does is, again, see, two keywords, mean, which is the mathematical mean, and squared means mathematical squaring. Okay, how this is used? What is the advantage of this? What it does is it calculates the average mean, right? Average squared distance differences between the predicted values, the values that the model predicted, and the actual values. And this step comes during the training phase because the model needs to be trained, right? And then tested. So during training, in order for you to adjust the weight of the different parameters and all, you use the loss functions, okay? So what it does, in simple terms, see here. So let's say these are your predicted values and these are the actual values. Oh, sorry. Y is the actual values, X is the predicted values. So what happened is, see this line, you draw, okay? So because see, you're training the data, you know the real values of the data points, right? That what is the actual value, that given the circumstances, okay, it rained today. Given this circumstances, it was sunny day today. Given this, it rained, it was cloudy. Okay, so those were the actual points. Now this is how your model predicted. So what you do, you plot all the points and draw a line through it. Okay, this is a linear classification because you were able to draw a line through it. Now, how do you calculate mean squared error? So this was the actual. This is what the model predicted. So you compute the difference between these two. Okay, and then you square it. So squaring, what it does is it highlights the outliers. So see here the difference. So let's say the difference, the predicted value is 5, but the actual value was 6. So the difference is just 1. So when you square it, it'll be just 1. But here, let's say if the difference between the actual value, so say the actual value was 3, but the model predicted 7. So the difference is 3. So when you square it, you're going to get 9. So compare 9 with just 1. So that brings out the outliers, okay, gives more importance to outliers. Like what happened here? We need to find out, okay? So this, like that, you sum all of these, you find the difference, square it, find the difference, square it, find the difference, square it. See, when you square it, even if it's a negative difference, it'll turn into positive. Then you will add all of those. You will add each of the differences that you had in your data points, and then you average it, like divide it by the number of predictions. So say in this example, we have how many? 1, 2, 3, 4, 5, 6, 7. So you would divide by 7. So in this, n would be 7, the number of data points. So you'll divide by 7, and this is the sum of actual minus predicted. Okay, actual, the red ones are the actual, and the predicted ones are on this line, what the model predicted. Okay, so this is the mean squared error. It tells you how far your guesses were. Okay, so how far your guesses were from the actual values. So you find the difference, square it, and average it out. Okay, so the lower the MSE, the lower the value, the closer you were to your guesses or to the actual weight. A perfect guess would have a mean square error of 0, which means your model was point to point, point to point. However, this is again a problem of overfitting. This is called as overfitting the model. When you train the model so closely to the data that your difference comes up to 0. Such models do not perform well in actual testing, okay, because it's not generalized enough, okay, when you bring your model so close. The goal has to be as close as to 0, but if it's 0, then you got to go back and look at your model or improve your training data. You have overfitted your model, which will not work well when put it in testing or in real life scenario. Another loss function is mean absolute error. So that was squared error. Now this is absolute, which means, again, absolute value. Mean is still we are going to do the average. Absolute means we are not going to square it, but we are just going to take the absolute value. See, squaring, what it did, it removed the negative sign, right? Because when we square a number, minus minus times minus is positive. Okay. So here, absolute value means, again, we remove the negative sign, right? Take the absolute value. It calculates the average absolute difference between predictions and actual values, and it is less sensitive to outliers. So like in the previous example, like when we see here this will still be 5, and here if the difference is 1, it will still be 1. So it's less sensitive. So compare 1 with 9. Oh, sorry, if this was 3, so 9, and this is 1. So compare 3 with 1 and 9 with 1, right? So it's less sensitive to outliers. Outliers means there will be one such data point which is way far away predicted, one scenario, okay? Because maybe the parameters are not weighted correctly or something like that. For in one data set point, it would have, or in one scenario, it would have predicted the actual value, which is way far away or no way close to the real value. That's the outlier, basically. Again, very simple. You compute the difference between actual, like what is the actual value the model should have predicted, subtract the predicted value from it, take the absolute because it could be positive or negative, sum everything, and then divide it by average, the number of data points that you have done. It gives you the absolute average difference between your predictions and actual values. It's not as sensitive to the outliers. Again, we know what are outliers. okay, as mean squared error is, and it is easy to interpret, okay, because the units of MAE are same as the units of the data being measured. Like if it's whatever you can call it, number of units or um, pounds or whatever the unit of measurement is, it remains the same. Here is a small example, which we will see it in action, a small Python program. So you should know what are the functions available. You don't have to necessarily write the code. There is a very tons of libraries available, but important one is scikit-learn. Okay, so here model evaluations, go to this website and see. Okay, see, it already has the mean squared error function available. You just have to give actual versus predicted and it will compute and show it to you. Let's see it in action. Oh, I want to show you this. Do you see this? Model evaluation, scikit-learn. Okay, see the mean squared error. It has so many functions available in it. Okay, so for classification, clustering, regression. Okay, so see mean squared error. And for classification, you have accuracy score, balanced accuracy score, F1 score. All these are available. All you have to do is go, say any one of them, click on it. So mean absolute error, which we saw, mean squared error. So you go here, click on it. Okay, it gives you what are the parameters, examples of how to use it. It is a must site to visit. Okay, gives you even see it's not possible for any course to cover everything, but if you want to know, learn more about anything, go there. So see F1 score, what it does. It also goes ahead and gives you examples of how to use it. Okay, what are the parameters? What do each parameters mean? Okay, so scikit-learn is very important. Scikit-learn and NumPy, okay, extensively used. Okay, let's see the mean squared error in example. So here it's the same example. I'm using online Jupyter notebooks. So here you import the metrics from metrics, you're going to import the mean squared error function. So from the metrics package, you're going to import this. All you have to do is give the actual values and the predicted values and just run it and it'll give it value. Here it is. It looks simple, but then the key is you have to go here, learn everything and see. Okay. So this was about loss functions. So any loss functions you would say, okay. There are different kinds based on all needs. This is the resource that you should be referring to, okay? And then use it in your model and test it. Try out the examples, see how each function, okay, differs. So let's say, for example, here, right? If instead of mean square error, if I import mean absolute error, okay? So instead of this, see now here it is 0.04666, and if I mean absolute error, and I have to change it here to absolute error. Let's see how it differs. See, it gives 0.2, right? So it doesn't consider the outliers, and the value is obviously a value would be different, okay? So which means your model in this scenario was this much away from the actual predicted values. So try it out. Jupyter.org is also a very good resource online, which is available where you can try your different Python codes, look at the examples, try it out, see the value that is changing. Okay. So that is all for today. So you know what are the loss functions and how you can use it, the resource where you can find all the loss functions, or at least from one of the libraries, which is very popular, scikit-learn. Okay, and try it out in the Jupyter notebooks. Try it out for yourself. All right. That is all about loss functions. In next video, we will talk about some other AI concept. Until then, thank you and see you all in the next class. Thank you.